Hello everyone, welcome to my channel. I am Deepak.R, studying in Sri Venkateswara College of Engineering from the Department of Cybersecurity. Today I am going to do a topic on discrete mathematical structure. Today I am going to explain about the topic Pigeon-Hole Principle. The Pigeon-Hole Principle is a fundamental concept in mathematics that states that if you have more pigeons than pigeonholes, at least one pigeonhole must contain more than one pigeon. It might seem simple, but its applications extend far beyond the realm of birds and boxes. Definition and explanation. In a nutshell, the pigeonhole principle states that if you have n items to be placed into m containers, then n is greater than m, then at least one container must have more than one item. This principle is often used to prove the existence of something even without explicitly knowing where it is. Simple example is that imagine if you have 5 socks and 2 dryers. You must put at least 3 socks in one dryer. Formal definition. For any set of n objects, if they are divided into m containers, then at least one container must contain at least n by m objects. The key idea is that the pigeonhole principle guarantees that a certain outcome must occur when there are more objects than containers. Applications in mathematics. The pigeonhole principle is widely applied in various mathematical fields, from number theory to combinatory. It helps to prove theorems, solve problems, and gain insights into the nature of mathematical objects. Number theory, proving the existence of numbers with specific properties. Combinatorics, analyzing arrangements and selection of objects. Graph theory, understanding relationships between nodes in networks. Applications in computer science. The pigeonhole principle finds its way into computer science in areas like data structures, algorithms, and security. Hash tables, avoiding collisions when storing data. Collision detection, ensuring that objects don't overlap in simultaneous. Cryptography, analyzing the cryptographic systems. These are all the applications of pigeonhole principle in computer science. The applications of pigeonhole principle in everyday life. We can encounter the pigeonhole principle in everyday situations even if you don't realize it. Crowded elevators. When a crowded elevator is full, someone must be standing close to another person. Traffic congestion. If there are more cars than parking spaces, some cars will have to park further away. Birthday paradox. The probability of two people in a group having the same birthday increases with group size. Variations and generalizations of pigeonhole principle. The pigeonhole principle has several variations and generations that extend its applicability to different scenarios. Generalized pigeonhole principle. If n objects are placed into m containers, then at least one container must contain at least n by m objects. Strong pigeonhole principle. If n objects are placed into m containers and n is greater than m, then at least one container must contain at least n by m plus 1 objects. Next, we are going to discuss about the limitations and exceptions of pigeonhole principle. While the pigeonhole principle is a valuable tool, it is more important to understand its limitations. The pigeonhole is not applicable to continuous sets. The principle doesn't apply to sets of infinite or continuous quantities, not a guarantee of distribution. The pigeonhole only guarantees at least it only guarantees that at least one container has more than one object, not how they are distributed. Requires discrete objects and containers. The principle works best with discrete objects and clearly defined containers. Historical context and development of the pigeonhole principle. The pigeonhole principle has roots in ancient mathematics, although it wasn't formally started until the 19th century. Ancient times. Implicit use of the principle in problems involving numbers and geometry. 19th century. Formalization and articulation of the pigeonhole principle as the mathematical concept. In 20th century, the expansion and applications of the Pigeon-Hole principle in various applications to new theorems and insights has been developed. Now let us discuss about the importance and significance of the Pigeon-Hole principle. This Pigeon-Hole principle is a very fundamental concept with wide-ranging reaching implications in mathematics, computer science, and other disciplines. Simplicity and power. This pigeonhole principle simplicity makes it accessible while its power lies in its ability to prove complex theorems. Problem solving. It provides a framework for solving a problem such as sets and distributions and other problems also. Thank you for watching my video. Please do like, share and subscribe my channel.